whether you're a geotechnical peer or you're another discipline in the civil world, is it is definitely complex and it is far from precise. So I think that's something you should take away from this discussion. And what I would say is, in the Piedmont region of the Carolinas, where I practice primarily, where a lot of you sit, there's a lot of topography issues. We've got varying conditions from a geologic origin standpoint. I would challenge you to think about our tried and true published correlations for geotechnical parameters. Are they valid? I think there's a misconception sometimes that Piedmont residual soils are pretty forgiving. So I'm going to let you think about that as we go through this. I think one of the biggest challenges we face, obviously, is that earth materials are not purely elastic like steel and wood and some of the other things we work with in the civil world. How do we account for those non-uniformities? Do we need to think about the methods of evaluation and assessment, and are they relevant? And then we need to think about the consequences of misdiagnosing and not understanding maybe what is actually happening. So as a geotech guy, I got to throw this in there. What we do is more than logs. It's more than data. It's more than topography. It's more than some software output. So where do I sit and where is this project we're going to talk about today? Upstate South Carolina. You guys probably more familiar with that due to Clemson's football team, but it's a beautiful part of the Carolinas. Project we're going to talk about resides and kind of sits on one of the three lakes in the western part of our state. Lake Keowee is the uppermost lake, which is sparsely developed. Lake Keowee is the middle lake where our project is. It's heavily developed. And then Lake Hartwell's down near Clemson, which is also heavily developed. So that's kind of the setting. We're pretty close to Georgia. We're pretty close to North Carolina. And we're dealing with some man-made features and kind of the impact of that. So when you think about living on the lake or developing on a lake, it's all about location. So our project sits on a peninsula of land that formerly, you can see the little river above and below our peninsula. So that river flowed from north to south. It literally, essentially, the channel for the river abuts our property immediately to the north. You can see it wraps our property immediately to the west and to the south. For those of you that need a little history lesson, Lake Keowee was established in 1971. They dammed up the Little River and the Keowee River primarily as a function of Duke Energy and their commitment for hydroelectric and then cooling water for Oconee Nuclear Station. The lake itself is quite long. It's the longest of the three lakes. There's 300 miles of prime shoreline. Average lake depth is 50 feet. It's almost 20,000 acres. And there's areas in the main channels that are over 100 feet deep. So you can kind of see where the site sits, some of the inherent challenges. Obviously, it's a beautiful piece of property, but certainly there's things to think through. So the first residential development that was conceived, for lack of a better word, developers developed a piece of property there on the lake, community called Keowee Key. So they built it, and sure enough, somebody's capitalized on the opportunity for lakefront property. There's multiple properties on the lake that have experienced similar types of failures that we're going to talk about today, but we're going to focus on these three lots. This is just the original developer plat. So they're about a half an acre. They slope downward to the lake, basically from the road, as this paper would go from north to south. History, I guess when you think about developing a piece of property or investigating that, I think we have a tendency to maybe overlook kind of the history. And as part of our work in this project, we were able to obtain a lot of documents from longtime residents at the lake. We're very grateful. We had the cooperation of those people to help us understand what was going on. But in 1987, and this sort of prefaces our project, geotechnical study was done for lot 46, which I showed you in the previous slide. And one of the most important things to note is within the body of this geotechnical report, 30-plus-year-old geotechnical report, they talk about slope failures that have occurred on lots 46, 47, and 48. going as far as the ultimate recommendation that there was a structure on lot 48 that ultimately needed to be removed for life safety concerns. So again, I would caution everybody and encourage everybody to do some digging when you get involved in something that is forensic in nature, or maybe even not. These are crude sketches. I'm not a good drafts person, but what we had was bits and pieces of work that had been done on each of the properties over the course of the last 30 years or so. So starting on the left, lot 48, that is a home that was built in 2006. That is the lot where a house was torn down and abandoned. The lot in the middle was developed in 2015. And then the lot on the left was the first lot developed back in the early 2000s, late 90s, actually. But what I want to point out with these topographic surveys is in the middle, you can see these very abrupt elevation changes. You know, when I say very abrupt, we're talking about 25 vertical feet over about the 10 to 20 horizontal foot distance. So there's some things going on here that I think if you were to walk that property, you'd scratch your head. So here's how it looks from Google Earth. You can see you've got 3 beautiful homes, all custom built. They overlook the lake, they've got dock, they got frontage. And what you'll see superimposed on this figure is the yellow box is the house that formerly existed on lot 48 that was ultimately raised. The red line is an approximation where that abrupt vertical feature existed across those topographic surveys. So you can see we've got about 600 to 800 linear feet of abrupt topographic change across these lots. What are they worth? Currently $5 to $6 million. So you can see the impact of something happening here is to be significant. Nothing special about our geology in South Carolina. The site is represented by the green star, so we're up in the upper Piedmont. Residual soils just weathered in place. Typically our soils are sandy silts and silty sands, varying consistencies, and then ultimately weathered rock and rock. Obviously the groundwater regime in this area, because of the lake and the rivers and other features, can be variable. But it's definitely a significant consideration in the way our materials weather, both physically and chemically. So that kind of goes back to that early slide. These are the old boring logs that we were able to retrieve from that 1987 report. So for some of you guys that are as old as I am or older, the old Atlanta testing group was engaged at that time to investigate the conditions on lot 46. And what you'll see is there's this upper horizon that's about 20 to 25 feet of relatively low consistency. They visually classified their stuff as sandy silt. We'll get into a little bit more about that as we move through this, but you can see there's a lower consistency upper horizon. And then as you would expect, things have a tendency to get stiffer, more dense as we proceed with depth. Here's some borings that were done in 2013. These were done in association with the development of the lot in the middle, or lot 47. And again, you can see we've got almost 30 feet of relatively low blow count silty sand. So again, there's some repeatability as we go from lot to lot to lot. There tends to be this upper horizon. And what's interesting about that is these soils have a tendency to be somewhat on the drier side when they're sampled using hollow stem auger techniques. So that's another consideration, is how does that play into these evaluations. So the properties in 2006 and 2015, which are lot 48 and lot 47, the one in the middle and the one on the left, those were evaluated by the same consultant who had done some work out there. And long and short of it, I won't get into the details, but their investigation basically included a number of borings, split spoon sampling, some Shelby tube stuff so they could run some triaxial compression tests to get shear strength parameters. They really didn't do a lot of index property testing. They put in some inclinometers because there was some indication, obviously, that there were some slope movements in the past. And through their work over the course of this 9 to 10 year period, they determined that the factors of safety were marginal, based on our review of the work they had done, had predicted factors of safety of about 1.1 to about 1.3. All the files we reviewed demonstrated circular surfaces. And based on those analyses and their results, they developed some solutions to enhance the stability of the slopes. So on lots 47 and 48, that's the one on the left, the one in the middle, they basically over excavated the natural slope above elevation 800 and reconstructed that slope as a 2-to-1 reinforced slope. The first part of that work was done on lot 2006. That was the first property developed. And then ultimately in 2015, they replicated that effort and did it for lot 47. So essentially, they reconstructed the lower 20 to 30 feet of a natural slope as a reinforced slope. On lot 46, that house had been there longer. That abrupt topographic change was not nearly as high. So, and the distress that they were observing was generally localized. So they basically constructed, for lack of a better word, a stacked series of planter boxes, I guess is what I would call it. And you'll see some pictures of that. And then they had some problems and some challenges controlling surface water. So they ultimately constructed a dry creek bed that flowed across 2 of the 3 properties. So you can kind of get the idea of what's going on. They're thinking they're resolving some stability issues with some reinforced earth strategy, some buttressing. And then ultimately, we get a phone call. It was a referral from an attorney friend of mine in 2019. This was in the spring. And what had happened over the course of about 3 weeks, where I had superimposed that red line on the aerial photo, those original headscarps, what we call the upper extents of the failure, they manifested themselves again. And unfortunately, at this point, the limits of the headscarp were very, very close to the northeast corner of the house on lot 48. They were very, very close to the back of the house on lot 47, and they were beginning to undercut and encroach upon a series of earth retaining structures that had been constructed on lot 46. So what did we do? We considered the data that had been previously collected. We went out and did a series of borings. We did, due to access considerations, we were able to get a track mounted rig across some of these areas. Otherwise, we had to do a lot of continuous wildcats, DCP type testing to try to identify consistency or relative density, and then took that body of work and we're able to model conditions. So what you see again, we found that same upper strata of lower below count sands, and what's really unique about these sands is they're relatively clean for Piedmont residuum, and we'll kind of get into that. But one of the oddities we noticed, at least in our work, the previous consultants in the borings they had done indicated groundwater conditions to be dry for the depth of their work. We had converted most of our borings to temporary piezometers, and we found that in fact the groundwater regime was up within the extents of the slope, or very near as you went to the toe toward the lake. Obviously, that's where the groundwater was. So that was something that obviously stood out as a difference in the 2 or the 3 different iterations of evaluation. So here's just a quick cross section, not to overcomplicate it, but you can see on lot 48, again, my crude drafting, what you've got is that upper strata of looser material. At the lower extents, that material was dug out and that reinforced slope was constructed. And you can kind of see it's planar in nature, the approximate boundary between those looser materials and then the medium dense to dense residuum. It's pretty well defined. And the way that plane dips is at about 20 to 26 degrees if you were to go toe to crest, crest to toe. So that boundary between those surfaces is fairly well defined. It's consistent, it's repeatable. Here's what they did on the intersection of lot 47 and 46. In order to resolve stability problems, they basically buttressed the toe, thinking that would resolve an apparent circular stability concern. And again, what you see is the repeatability in the inclination of the boundary between that loose material and getting down toward weathered rock. And, I'll comment a little bit about the materials themselves. It's kind of interesting. We don't see a lot of relatively clean sands out here, but we have materials, natural residual soils that have fines contents, in that 10 to 15% range. And that was typical. And what we saw is those upper sands, when we looked at them under a microscope, the grains were actually sub-rounded to subangular, which is somewhat interesting because typically we would see subangular to angular on our coarse fractions. Then you go to the underlying strata, more traditional, typically greater than 20% fines. The sands were obviously subangular primarily, and then weathered rock. So what I would say here is the moisture conditions are somewhat unique, generally on the drier side where we're able to sample. The fines contents were extraordinarily low within that looser strata. And then that boundary is extraordinarily well defined between those materials and then stratum number 2 and stratum number 3. So as any good geotechnical professional would do, we were fortunately able to get some relatively good UD samples, even in those sands. So it took some time, and we pushed a number of tubes and got surprisingly good recovery. So to work backwards, obviously, we ran some CU triaxial compression tests to get a feel for what we were dealing with. And to summarize, there's some consistency. Those lower blow count materials, 4 blow material, about 16% passing the 200 sieve, and had about 37-degree effective friction angle. Maybe a little bit higher than published correlations, but controlled environment. I know it's a little sliver out of a Shelby tube test, but not necessarily unreasonable. A deeper sample from a slightly more dense residual material at a lower moisture content obviously had a little bit more pass in the 200 sieve, and that friction angle was comparable at 34 degrees, and that's the effective. And you can see there's not a significant difference due to the grain size characteristics versus the total stress state and the effective stress state. So in looking at this, we went through and performed some analyses and tried to figure out what is it we should be modeling. And since we knew from our work that this slope had experienced recurrent movements, and when I say that, the first documented movements were in the early 70s, shortly after the lake was filled. Then we had other movements that were noted and recorded in the late 70s. Then we had movements and additional movements that were noted in the late 80s, in the 90s, the early 2000s. So the question then became, with each progressive movement, how do we account for that in our modeling? So we said, okay, if the materials move and with each movement, the shear strength is reduced to some extent, how do we do that? So we ran basically some residual direct shear, and we ran that on the same sample we ran the CU triaxial test on. So if we think about how that might compare, the direct shear results could generally be considered consistent with the effective strength parameters on the CU test. So we got 38 degrees from the direct shear on the sample, and then which is excellent agreement, whether we were lucky or not, or whether the materials are that homogeneous throughout that sample we took, I don't know, but we had very good agreement in terms of direct shear versus effective shear strength from the CU test. Then we cycled the material as you would in a residual direct shear, like you might consider for slick and sided clays or materials that have inherent natural flaws. And what we found is in that cyclic residual test, that friction angle drops considerably. So we've got about a 25% decrease in shear strength if we consider we're replicating those movements in a controlled environment. So we go from about 37 or 38 degree effective strength parameter down to 29 degrees. So we need to think about, okay, how does that impact what we're doing? So what we did is we had an as-built done we retained a surveyor to go out and do an as-built so we could field locate where that headscarp was. We were able to overlay that with the previous topographic drawings I showed you. And sure enough, where this new slide manifests itself is not coincidentally in the same place as the original slides and failures. So again, I talked about timeline and timetable. There's nothing unique about this. And to really simplify it, if we think about what I had said before, we know that the boundary between those looser, less dense materials and the underlying strata that's more competent residual, more weathered rock, if you just apply an infinite slope theory and we use the strength parameters from the residual direct shear, we get a factor of safety that's approximately unity. So it's close to 1, and with some manipulations in groundwater table and things like that, maybe maxes out at about 1.1. So maybe that was a good prediction. Maybe that was a good way to consider how this slope might behave in the future. So we used that residual data as part of our modeling process. And we were able to really drill down and get a better understanding of what was going on and why. So everybody, as part of a presentation, you guys want to see dead bodies, you want to see the chaos, and you want to see the repercussions of maybe the misdiagnosis or the poor predictions. And when we arrived on the site, this is what we were able to see. It was obvious that, in fact, the slope had begun to move again. The ground distortions were significant. The picture in the upper left is a brick paver walkway down near the shoreline, which is on the very far left side of where that headscarp is. So kind of on the left side of this picture, you can see the walkway as it goes down to the lake. The picture in the upper right is the upper extents of the headscarp that is now back cutting their lower level patio and deck. And that headscarp's about 3 feet tall. So from a perspective standpoint, what's the vertical distance? The picture in the lower left, and I'll go back to the slide before, is about where that arrow is pointing on lot 47. So the middle lot, and I talked about this idea of a dry creek bed to divert surface water. Unfortunately, the dry creek bed wound up being constructed over the upper extents of that headscarp. And the vertical distance at that location, and again, the slope is taller, there's more demand, more driving force. The vertical distance of that headscarp is almost 5 feet. And then on the lower left, this is looking across toward lot 46. And in the middle of that photo, you see what I talked about was this buttress or these stacked planter boxes. And again, that buttress, the intent there was to provide resistance to those driving forces, you know, with the circular surface being considered. And you can't see it well in this picture, but the headscarp is basically cutting through the center of this photograph. So there's some small timber crib walls, and that the headscarp is beginning to undercut those upper crib walls. So this is what we saw. Obviously, this is not a small failure. It's consuming 3 lots. The distance of the headscarp is pushing about 800, 900 feet. So the solution, obviously, that's the thought-provoking part, is how do we do it? And what these pictures represent is all of that existing infrastructure. How are we going to stabilize these massive slopes? So from the road down to the lake is about 90 feet on average. So it's a significant mass of earth. You know, we can't underestimate Mother Nature in this. Yeah, the slopes moved. It's moved quite a bit. It's impacting infrastructure. It's encroaching very close to these $1 million+ homes. And there's a fishery about 8 miles from this site that recorded 123 inches of rain in 2018. So fast forward to us getting a call in April of 2019. You can see that this wetting phenomena, very extreme. Our normal rainfall in the upstate is about 48 inches a year. So we had almost 3 times that in the vicinity of the project. And then we looked at historical data, and you can see we've had historically wet years in 75, 79, 92, and on and on and on. It's not coincidental, I don't think, that these slope movements occur generally within the historically wet year or shortly thereafter. And then we've got cyclic historically dry periods. So we go through this cycle. and the slope moves, it reaches about unity, it sits still for a while, and then those movements are re-engaged. So again, we start connecting the dots and we look at not only what's below the ground, we look at what's happening atmospherically. And that lake level, just so you guys may have some questions, does that lake level rise and fall significantly? Not more than about a foot or two historically. So the rise and the fall of the lake level really has very little impact necessarily on the stability of these slopes. So how did we think through this? What were we going to do to help these people maintain the value of their asset, restore the safety of their property, eliminate those risks? These are all people that are retired or near retirement. This was sort of their dream home. What would they leave their kids? Due to some restrictions by Duke Energy and the Corps, all of the repairs have to be initiated above elevation 800, which is the high water level for the lake. So if you think about that slope, and I didn't share this with you, but from the crest of that slope out to the channel, there's about 170 feet of vertical relief. So the channel was deeply incised right in front of our property. And if you recall, that's where that sharp 90-degree bend to the west is. So you can see that river's been just cutting and cutting and cutting away at the toe of the slope. So we couldn't get out in the body of the lake. There wasn't a stabilization strategy to start out and do some kind of crazy underwater repair. So we're limited to starting at the shoreline and above. Some of the first things we had to do to improve the stability of the slope just for the construction of the improvements, all of these guys had built rockery walls and other things that were putting demands on the slope, for lack of a better word, surcharging. So the rockeries had to come down. Those timber crib walls had to come down. Anything that was putting an additional demand on the slope ultimately had to be removed. So that was done in the summer of 2019 in anticipation of the repair ultimately being accomplished. The value of the removed improvements alone, just these rockeries and little ponds and whatnot, they had over $800,000 cumulatively in landscaping improvements across those 3 lots. So that was money that was unfortunately just wasted. With that, we obviously had to redirect surface water from the street, from the houses. So we had a lot of pipe laid out over the ground and strategically collected and taken down to the lake. So we had to get the surface water the best we could off the slope. And then we thought about, should we just go down the path of a solution or two as the owner's consultant, or do we open it up to the industry experts? So what we agreed to do and what the owners endorsed was having 2 different specialty contractors consider the data, visit the site, do their own analyses, and come up with solutions that they, A, thought were buildable, and secondly, thought were cost effective. And again, these are reputable contractors, one of which is global, the other is definitely a southeastern firm with a lot of experience, particularly at the lake, fixing other failures and slides like this. So the first approach was basically to stabilize that slope with what we call patterned ground anchors. So for lack of a better description, it's a big concrete block, tiebacks, multi-strand tieback anchors all the way back into competent rock to develop resistance. And then that load is distributed over the face of the slope and that mass is held in place. So their solution would have resulted in these beautiful big concrete blocks on the face of the slope, basically from the shoreline up to about elevation 830. So the lower half of these lots would have been impacted by these not so pretty features. Yeah, they could have been buried, but then you get into the idea, we're going to place new engineered fill over top of these buried concrete elements. And then the collateral work just kind of got overwhelming. And then the cost for that solution was about $2.1 to $2.5 million. So on a per anchor cost for the layout that firm came up with, it worked out to about $50,000 per pattern ground anchor. So roughly there was 40 to 50 pattern ground anchors across those 3 properties to improve the stability of the slope. So the second approach by a more local contractor who had fixed other slides and failures out on the lake over the last decade, what they proposed was a very unique solution, but very practical. And essentially what they developed as their concept repair was a micro pile supported grade beam. So you had vertical piles, you had battered piles. These were cased 10-inch diameter elements. And then within that grade beam, there's tieback or a series of tiebacks, regularly spaced tiebacks. And that went across that entire shoreline. And I'll show you some pictures of how they're getting ready to do that. But we have basically almost 700 feet of micropile supported tied back grade beam down along the water line. That was their solution. And their estimated cost was about $1.4 to $1.7 million. So about 20%, 25% less than approach number one. And that gave the owner some flexibility to construct or reconstruct certain improvements above the grade beam. So ultimately, the owners collectively, they all had to be on board, and that was not easy getting them to be like-minded. They're already spending well over $100,000 for our work. Each of these two specialty contractors asked to be paid for this preliminary effort. So that was about another $60,000. And they ultimately selected approach number two. So my crew drafting skills, again, what you'll see is I've superimposed a cross section essentially that runs down approximately the center of lot 48, and the grade beam is down near the shoreline. The black lines represent the micro pile. So you've got the vertical pile in the front, you've got a batter pile that's being loaded in tension that's installed at a batter, and then you've got these insanely long tieback anchors that go a significant distance, upwards of 60 to 100 feet, depending on the geology and that rock interface. And then that entire mass is retained by this system, this micropile supported tied back grade beam. And then above that, they'll reconstruct the slopes at a 2.5 to 1 horizontal inclination. The design accounts for some surcharge loadings. I don't know what was ultimately resolved. Most of the homeowners are not going to put back the rockeries and the patios and the ponds and the timber crib walls. They're done with that. So they're just going to have a grass slope down to the lake. So conceptually, you can kind of see the solution here in section view. So they've actually just started this project, so I don't have a lot of sexy pictures yet. But essentially, to build the area where the grade beam and the micropile installation needs to occur from, they've got to create a bench. And you can see the access is extremely limited. So they're bringing equipment in some cases by barge. In other cases, they've created a road around the western extents of lot 48. And they've had to remove the toe of the existing slope. So there's a temporary soil nail wall there so that they can safely access that shoreline. They've had to buttress the shoreline with some additional gravity measure elements. So you've got some large, for lack of a better word, gravity type segmental block units down along the shoreline, additional riprap protections, sort of to buttress that toe below the bench. And then that's continuing. So they're nailing basically from west to east to establish that platform. So again, it's challenging, and you can see access is horrible. The lake is close. The amount of infrastructure that had to be removed and disturbed. You can see the big, beautiful buttress is removed. So all of that collective effort is kind of where they are now. And hopefully this project will finish this summer, and we'll be able to update this presentation with all the good stuff. But to kind of close this thing out as we get close to time, the takeaways, I guess, for anybody in the civil discipline, whether it's structural, general civil, geo, when you get called in to look at something that's not performing like it should, or maybe it's underperforming like this slope was, you really got to think through the obvious. You got to take the blinders off. You got to lean on your peers. And absolutely, you better put your ego aside. We might all think those initials behind our name mean something, but I will say you'll be challenged, you'll be humbled, you might even be humiliated at some of your first attempts. But forensic work requires a lot of out-of-the-box stuff. And then I guess the second question we talked about, are you in your comfort zone? Is this the type of project you and your firm would even want to get in? We know residential work typically, not to make this a business discussion, but it's hard to collect money. Things get crazy. You got multiple homeowners. Everybody's got a different mindset. But do you want to get into this? And is it something you feel comfortable with, either as an individual or your firm? I can't stress enough, when you've got a project where something's underperforming or maybe has actually failed, where you've got such a history, you've got to ask these questions. You got to round up all the historical stuff you can. So it's online stuff, it's FOIA requests, it's talking to homeowners, talking to the HOAs, and I'll get into that a little bit at the end. You got to get enough information. You cannot go out there. Usually you get one bite at the apple to get what you need. You know, the performance of this slope was unpredictable. So you got to get a lot of stuff. You got to get it efficiently. You definitely have to plan. Access in this case was horrible. Getting drilling equipment and sampling equipment in, even running the topo was challenging and time consuming. And with slope stability, I mentioned at the beginning, it's far from precise. Do you really have an understanding of shear strength and how to apply those values and what they mean? What's the impact of groundwater and slope stability? Would it have made sense to drill a 60-foot boring out there and not encounter groundwater? So you got to think about that. Was that relevant? Was that a consideration that was overlooked in those initial analyses and those predicted modes of failure? And then you've got to look at all the modes of failure. Slopes can move in a lot of different ways. Don't want to make this too technical, but you've got to consider that. You can run circular, you can run block analyses, you can look at things statically or pseudostatically, you know, if you want to consider seismic things. But you've got to consider all these modes of failure and then kind of work your way back toward what makes sense based on the information you've collected. And then sensitivity analyses. This was a case where the movements were recurrent. So we were able to connect the dots, and, you know, with each movement should be a corresponding reduction in shear strength. With each wetting event, there's a demand and a you know, phenomena there at that interface of those cleaner loose sands and those denser materials that have more fines. And then what I learned in this project, and I'll say this, is we're a consultant. All of us on this call and this Zoom meeting, we're consultants. We're not our client's therapist. And it stinks. There was tears, there was anger, people were upset. This is an emotional thing when an owner has to face the obvious, and the obvious is millions and millions of dollars in repairs. And I know that's hard. We want to be compassionate. We want to do all that, but we've got to be objective. You know, delivering bad news or difficult things is not easy. It's not supposed to be, but you got to do it with grace. You got to build confidence, you know, but again, understand your role. So I'll kind of close this out right at about 45 minutes. I want to reiterate, and this is for everybody, the general civil guys, us as geotech guys, structural guys, slope stability is far from precise. Just little tiny changes in modeling or assumption can lead to inaccurate predictions. And you sort of have to work through that and resolve that in your mind. It's not just a shallow foundation project, or it's not just designing a segmental retaining wall. It's something that it's iterative in nature. You have to understand boundaries. You have to understand thresholds. You have to understand what drives and the mechanisms of failure. As a consultant, would you want to be the guy that was involved in this project from 2003 to 2015? We all are fearful of litigation. We're fearful of dropping the ball. It's embarrassing when we screw up, but you have to think about that. And it goes back to that question: is this in your comfort zone, and is it something you would want to tackle? In this case, all three of those owners had put a lot of confidence in the firm that was involved in that middle period of these lots being studied. You know, it's a challenge to earn our clients' trust. We talked about the consequences of assumptions and inputs for shear strength and groundwater, and how to account for that and the variabilities in our modeling. The implication of putting additional demands on these slopes. Everything sort of unfolded in a way that all of these improvements that were attempted stabilization efforts, as well as amenities, all were constructed above that failure plane. So all it did was add driving force. The owners were never cautioned about that, even though that consultant was involved. I can't say enough about the financial consequences. these people have worked hard. The one owner has one time owned multiple Subway restaurants. The other guy's a veterinarian. The other guy's a textile executive. This is eroding and cutting into those retirement funds significantly. It's stressful. Some of them are in therapy. It's just overwhelming. And we talked about delivering tough news and then being able to explain to somebody what's happening and why, and to do that with grace, and to be understanding. And then when you do get a pat on the back, and I will say this, in my 35 years, we don't get a lot of praise as civil engineers. We deserve a hell of a lot more. But when you get them, accept them with humility. It's a real compliment when your clients say, thanks, you've done a great job. So again, I kind of close with that. What we do in the civil world, it's not sexy. Most of our good work is rarely seen. It's below grade. So I'm going to build up our profession a little bit, and the fact that the geotech guys, I think, unfortunately, were commoditized, and maybe all of civil for that matter. But if you guys want to learn a little bit more, there's some good technical references that I encourage our engineers here at ECS to look through and grab. The first two, those are texts that I've used, significantly, and they both bring thought-provoking commentary. The methods are consistent, but each of them touch on different things based on the work done by each of these authors. And then perhaps one of the best books you could get as a practicing geotechnical guy, and this book is out of print. It's been out of print since the 60s, but there's a whole book dedicated to measuring shear strength with the triaxial test. And it really walks you through the importance of what parameters to run the test at, what stress states to consider, how to condition those samples, what to do with samples that are not intact versus intact samples. So if you're interested, these are the kind of tools you should have in your toolbox. And there's a million other references out there, but these are things that are dedicated to the practice of slope stability, improving slope stability, and then measuring parameters that are ultimately necessary for the analyses. And that's my shameless plug. I grew up in Baltimore. I'm a long-suffering Orioles fan, long-suffering NC State fan, and certainly the Ravens have got their 2 Super Bowls, but I appreciate everybody taking the time to hear about this. I left a lot of specifics out in the spirit of time, but if anybody's got questions, I'm certainly glad to take a few. I think we've got, 10 minutes or so. So certainly appreciate any comments or feedback or questions.
Steve, thank you very much. That was excellent. Really appreciate that. Welcome any questions in the chat if you have them. I'll start off with a question, Steve.
Yeah.
Was this isolated in the development on the lake? I would imagine there were probably other properties that faced this. Do you know of those and what actions they took?
Yeah, there's probably upwards of about maybe a dozen documented failures that are very similar. They're large scale slides. They're not rotational failures. And the consistency is on the north side of the lake, as you go north and west, there is this predominant sub-rounded to subangular, for lack of a better word, relatively clean sand. If I were to show you guys this stuff, it looks like it came from Wellington. It looks like beach sand. So yes, on the north and the west flank of the lake, this phenomena seems to be reoccurring over the last 15 to 20 years. More and more of these are revealing themselves, as properties, get developed.
Thank you. Our next question comes in from Mr. Albert Weaver. Thank you for that question. What is the projected life of the fix?
That's a great question. I don't want to speak for the designers. I would assume they're anticipating that these houses would probably remain in the family for 30, 40, 50 years. I think they're going into it cautioning those folks that nothing's permanent. Certainly other failure opportunities exist. So yeah, I wish I could answer that. I don't really know if the designers were willing to even put a number on it, for lack of a better term.
All right. Our next question comes from Joe. Appreciate that. Were the owners able to collect any damages from the previous consultants?
You know, the general feedback they have gotten from council is that the statutes have run, which means they're not likely going to collect. And I want to expand on that just a bit. There's the consultants who have their fingers on this, or the one consultant. But the HOA is the other party in this that is not squeaky clean. After that 1987 report was authored and published, those three lots were never to be sold by the developer. It's in the meeting minutes, it was recorded, and that was other information that I didn't share with you guys, but the homeowners association owned documents that board voted and agreed to never sell those properties due to these inherent risks. And at some point in time, that got lost in the shuffle for the sake of $1, and those lots were remarketed. So there may be some recourse against the HOA, but the proceeds from that policy are less than $500,000. That's my understanding.
Yeah, that's interesting. All right, next question comes from Tom. What friction angle did the specialty contractor use to design the fix? And what factor of safety was used in the design calculations?
My understanding is they reduced for that lower strength residual, they reduced the friction angle in their modeling to 25 degrees. So they were uber conservative, to say the least. And they were working back toward a factor of safety against global instability of 1.35. Why they picked that number, I think we generally believe 1.3 is the lower bounds. And if you start going beyond that, I think the cost of this repair would have become even more prohibitively expensive. Even the micropile supported grade beam would have ultimately been closer to the pattern ground anchor solution. So in their modeling 25, long-term factor safety was 1.35. So sort of toward the lower end of what we might consider as acceptable.
Thank you. More questions coming in. This one is from Janet. Are there any drains incorporated into the design?
Well, the surface water at the crest of the slope, yes, is being collected and diverted down to the toe through a number of different collection devices. And then beyond that, within the reconstructed slope above the grade beam, they are going to install basically horizontal strip drains, for lack of a better description. It's like pushing a wick drain in through the face of the slope. So it's sort of a hybrid. They're collecting surface water near the crest, taking that below grade to the lake, and then within the reconstructed 2.5 to 1 slope above, they're going to use horizontal strip drains. Those will be pushed in with a mandrel, and then those will discharge down toward the slope, down toward the toe.
We got 2 comments. One from Brian. I was an expert witness in a legal case 2012 to 2013. Failure plane was along PWR soil interface per extensive inclinometer data. I see a lot of parallels in both of our studies. And then Jay said, not a question, just a comment, but very interesting case study. And I appreciate that you took the time to describe context from different perspectives, consultant, client, etc., and what the project meant to each of them. And I will second that. You know, it's interesting about how sometimes engineers can play the role of therapists.
Yeah, we drank a few gin and tonics, a few beers, smoked a couple cigars, you know, had to counsel. It was not easy. It was not easy. You know, and again, you know, it's part of what we do. We're consultants, we're people. We should be able to get our ideas out there, you know, concisely in a non-intimidating way. And it's tough. It really is. But with practice, not so bad.
So, okay, last call for questions. We got 5 minutes left.